All right, today we're going to talk about kinetic energy. Okay, we've seen that word kinetic before. We saw it when we talked about friction. We had the force of kinetic friction. That was a force that was occurring when the object was sliding or moving along a surface. Okay, so it was moving. Same idea here. Kinetic still means moving. It's the energy of something that is moving. Okay, so in order to have kinetic energy, object must be moving. Kinetic energy, the formula is 1/2 the mass of the object times the speed of the object squared. And be careful, this is speed, not velocity. Okay, so we don't care what direction it's going. Therefore, we don't care if it's positive or negative. Okay, now the units. We want our kinetic energy to be measured in joules, just like our potential energies were measured in joules. In order to do that, we need to make sure that the mass is given to us in kilograms, and we need to make sure that the speed that we put into the formula is in meters per second. Okay? Another thing about kinetic energy, it is a scalar. It does not have a direction associated with it. Okay? And it is always positive. Again, we don't care about the direction here, so we shouldn't have a negative going in there, but even if we did, we'd square it and get a positive. And our mass is always going to be a positive mass, so we're going to get a positive kinetic energy. All right, let's go ahead and take a look at a problem. This problem says, what is the kinetic energy of a 2,200 pound car moving at 45 miles per hour in joules? So we want to find our answer in joules. So we're going to see how big is a joule. Okay, does this car have like 5 joules of kinetic energy or thousands of joules of kinetic energy? Okay, how big exactly is a joule? All right, so step 1, as always, draw ourselves a picture. Okay, there's the car. Okay, car is moving along. All right, what do we know about this car? Well, it's 2,000 pounds. 2,200 pounds. Okay, that's a weight. We need to convert that to a mass. And we do know that here on Earth, okay, that 1 kilogram is approximately 2.2 pounds. If we go to a different planet, that's going to change because the gravitational field constant would change. But on Earth, we can use this for our conversion units. Let's go ahead and do that. 2,200 pounds. I want to convert to kilograms, so I need to get rid of the pounds. So I put it in the bottom. And it's 2.2 of those for every 1 kilogram. Pounds is going to cancel out. We're left with 2,200 kilograms over 2.2, which is 1,000 kilograms. Okay, and kilograms is a mass. So we now know our mass is 1,000 kilograms. What other information do they give us? Well, they say the car is moving at 45 miles per hour. Doesn't say which direction, doesn't matter, it's a speed. Okay, but it's 45 miles per hour. Well, I need this to be in meters per second, so I need to do some conversions. So 45 miles per hour means 45 miles every 1 hour. I want to get to meters per second. Well, I want to cancel miles, so put it in the bottom. And I want to get to meters. Well, if you run track, okay, or if you've had to run the mile in gym class, you know that if you go around the track 4 times, you've run 1 mile. 4 times around the track is 1,600 meters. So I've got the miles taken care of. Now I need to get the hours and the seconds. Well, hours is in the denominator, so I put hours in the numerator, help cancel it. I know how many minutes are an hour. I know there are 60 minutes in 1 hour. Great, got rid of the hours, but now I have minutes. Need to get rid of the minutes. Minutes is in the denominator, so I'll put it in the numerator in order to cancel it. And I know that there are 60 seconds in 1 minute. Minutes canceled, left with seconds in the denominator. Go ahead and multiply across the top. 45 times 1,600 is 72,000. And the only units up here are meters. over 60 times 60 is 3,600, and the only units left in the bottom are seconds. Go ahead, divide there. We're going to get 20 meters per second. So we've got our mass of 1,000 kilograms. We've got our speed of 20 meters per second. So we've got our picture and our givens here. Next, we need to write down what we're trying to find. We're trying to find the kinetic energy in joules. So the kinetic energy is what we're trying to find. That's our question mark. Got a little space left up here. Okay, so we've got picture, givens, find, equation. Well, kinetic energy is equal to 1/2 the mass of the object multiplied by the speed of the object squared. Go ahead and substitute in. The mass is 1,000 kilograms multiplied by our speed of 20 meters per second squared. Go ahead and solve that. We're going to get 200,000 joules. So a joule is a fairly small unit, considering that we've all traveled in a car, okay, at 45 miles per hour. So we've had about this much energy before.